I'm going to show how to implement a version of the Mandelbrot set using Affinity Photo's procedural texture filter. I was first introduced to the Mandelbrot set in the back pages of Scientific American. There was an article entitled Computer Recreations, and every month they would show you a different little algorithm you could implement on your home computer. They ranged from rotations of the hypercube to the three-body problem, and like a lot of people, I had just gotten a home computer at the time, and when the Mandelbrot set came out, it was super fascinating to see all the different amazing colors and complexity of this relatively simple formula. The Mandelbrot set quickly became an icon of chaos theory due to its bright colors and extreme complexity. To understand the Mandelbrot set, you have to understand a little bit of complex number theory. In complex numbers, you have a real value and a complex value of the number. So for the complex number of z, it's going to be a real value x, and then added to that is a complex value where I is the square root of -1, and then y is essentially a real value. One way to interpret complex numbers is to plot real numbers along the x-axis and then the complex numbers along the y-axis. In order to determine if a complex number is a member of the Mandelbrot set, you take the magnitude of that number and check to see if it's greater than 2. If it's greater than 2, you know it's not a member of the Mandelbrot set, but you usually retain the number of iterations it's been through and assign that to a different color. To perform an iteration, you calculate the previous value of z squared plus the original value of z, and that becomes the new value of z. To square a complex number, you use the FOIL method where you take x plus iy squared is x plus iy times x plus iy, and you multiply the first times the first, which is x squared, the outer times the outer, which is x times iy, and then the inner, which is iy times x. So you have two of those, so that's 2ixy. And then the last, which is iy times iy, which is I squared, y squared. And then these parts, since I squared is negative y squared, this can be combined with the other real component, x squared, so you get x squared minus y squared, and then the complex component is 2xyi. To compute the magnitude of the complex number, you take the square root of x squared plus y squared. Now, that is the same as the length, and so when we implement this, we'll be using the length function. The other thing that we have to consider is we can't do an iteration like this because this involves a loop. So around here, you would have this loop that's iterated a number of times. So in order to sort of fake the loop, I'm going to set that up, just have a series of variables, and each one is based on the previous variable. To get started, I'll start with a blank 1024 by 1024 image, and I've colored it black, and I've added a live procedural texture filter. To get started, I'll start with variable v0 equals vec2 of rx comma ry times a divided by w. I'm also going to divide by b, which will allow me to zoom in on the Mandelbrot set. Just see what that looks like. I'll assign that to all three colors and add two real values for my a and b. I'll just set those both to 1. Okay, so now I can move this around and position it so when I want to zoom in I can do that. To calculate z squared plus z naught, I'm going to start with a new variable, v equals a vec2 of v0 dot x squared minus v0 dot y squared, and then plus v0.x. So I have to add on the x component, and then the next part is 2 times v0.x times v0.y, and I have to add on the original y component, which is v0.y. Okay, and now to compute the Mandelbrot set, I just take the length, so the magnitude of this is the length of v, like that, and so it looks like that. And I'm also going to multiply, I'm going to add a 0 to 1 slider here, call that I, and I'll just have a fader on that so I can control the grayscale range of this. So times I, and I can zoom out a little bit to see what that looks like. Now the Mandelbrot set cuts off at a value of 2, so if I bring this down to about 0.5, that should be about the cutoff for the Mandelbrot set. Now I'm not able to add a loop in the procedural texture, so instead of that I'm just going to copy this variable and paste it here. And I'm going to change the name of this first one to v1, and I'm going to leave this one v, but I'll change each of these zeros, that to a 1, that to a 1, but I have to remember to leave this as a 0, and then I'll change this to a 1 and this to a 1, and leave this v0.y as a 0 there. The equation looks like this now. And now I can start to see the shape of the Mandelbrot set emerging. I'm going to keep doing that until I get additional iterations of this. That's after 3 iterations. This is 4 iterations. Now I noticed a strange sort of phenomenon that starts showing up here. If I zoom out, I get that. And if I go up to 8 iterations, now at 8 iterations I'm seeing this sort of window around here. I'm going to add sort of a rainbow gradient to this. It looks like that. And then if I go in and adjust the fader, you can get a nice range of colors on this, like that. And you can zoom in on different parts of this using the zoom factor, but you have to sort of pull it off to the side. And as you zoom, it shifts, so you have to keep moving it to get to the part that you want to zoom in on. So that's 8 iterations. That's about as far as I've taken it. You could maybe add additional iterations. In this case, I've just taken the length of v, the latest iteration, but you could take the length of each of those and assign them to a different color. Then you'd have something that represents the original Mandelbrot set, how it was originally implemented. But I sort of like how this looks a little better. It gives you more of a unique flavor to the whole thing, and you can get some cool regions of it to show up with this. Let me know if you have any comments or questions, and thanks for watching.